In this video we are going to determine the enthalpy of an overall reaction given the enthalpies of formation from either the problem you are given or in the textbook. So, this is the breakdown of salt. From the book we can determine that Na plus has an enthalpy of negative 240.1. We can also determine that Cl- has an enthalpy of negative 167.2. And we can also determine that NaCl has an enthalpy of negative 410.9. Now, for all of these reactions, how to figure out the enthalpy will be products minus reactants. The only time that it isn't is if you are using bond energies. So we add up the total products, which is negative 407.3, and subtract the negative 410.9 to give us 3.6. Which is in kilojoules per mole. And since the enthalpy for the overall reaction is positive, we can determine that the reaction is endothermic. If it were to be negative, it would have been exothermic. And that's how you find the enthalpy of formation for an overall reaction. Here's a practice problem for you to try on your own. Alright, so we got negative 64.8 kilojoules per mole as our answer. And from that answer we can tell that the reaction is exothermic. And if you didn't get that answer, then you probably made a sign error in your calculations somewhere. Okay, so for our next reaction, we are going to find the overall enthalpy of a reaction using Hess's law. And Hess's law is when you are given a series of equations and you either have to multiply or reverse one or two of the reactions. So for this one, we cancel out CO2 from both sides because it's an intermediate, and the same for SRO. Then we can just add all of the reactions together, including the enthalpies, to get our overall reaction of SR plus C plus 3 halves O2 yields SrCO3. And then your overall answer is negative 1220 kilojoules per mole. For our next reaction, we have a series of reactions where you have to reverse and double a reaction. For this one, as you can tell, we need two C's, so for the first one we will multiply that by 2 right away. And since we multiplied that by 2, we now have 2 of everything. And then bottom reaction, we have to have the CH4 on the right side, so we're going to reverse that right away, which means we just change the sign on the 206 to a negative. Now we can start canceling everything. So the 3H2 cancels with the 3H2s on the right side. And then this CO cancels with this. And then this one cancels with this. Now we are left with two C's, 3H2s on one side, and CO2, CH4, and H2O on another side. So then we cancel out one of the H2Os with this one. Then we are left with our overall reaction of 2C plus 2H2O yields CH4 plus CO2. Now by Hess's law, we add up all of the enthalpies of the individual reactions. So we add up 2 times 131.3, negative 41.2, and negative 206.1. to give us an overall enthalpy of 15.3 kilojoules per mole. Here's another practice problem for you to do. Find the enthalpy of the overall reaction using Hess's law. Okay, so for our answer, we got negative 11 kilojoules per mole. We had to reverse this reaction and this reaction. We also had to multiply this reaction by 2. And then this one we had to multiply by 3. And then when we canceled this with this, these 3 with this. We canceled the 3 COs with the 9 COs to get 6 CO. And then we had 6 FeO left over, 6 CO left over, 6 Fe left over, and 6 CO2 left over. Then all we had to do after that was multiply by 1/6 or divide by 6. So we divided the final reaction by 6 to get FeO plus CO yields Fe plus CO2. And if after we did that, we'd divide the answer we got, which was negative 66 by 6, to get negative 11. Now you should be able to find the enthalpy of an overall reaction using Hess's law.